So now we're going to talk about the last two types of measurements for describing the relationship between two variables. Two methods showing the relationship between two variables. One is the scatter plot, and the other one is the correlation coefficient. A scatter plot is really good for looking at the relationship between two variables that are continuous in nature. So by continuous, I mean a variable that starts at, say, 0 and goes all the way up to infinity. Presumably, it could be very high. So we could have, say, age. If it's not categorized in groups, age is considered a continuous variable in that respect. You could also have, say, cholesterol or shoe size and, IQ. Things that can be a number that is not necessarily categorized are considered continuous variables. So the horizontal axis would show the independent variable, which is the predictor variable, usually called x, and a vertical axis actually shows the dependent variable, which is usually called y. But that's not necessarily always the case. You can just look at two different variables, regardless of which one is independent or dependent, just to see if there's a relationship qualitatively between two variables. And if the dots that you see along the two graphs form some sort of, predictable pattern, then there is, in fact, at least likely a relationship between the two variables. But this relationship is really only described qualitatively. Again, here's a relationship between father's education and mother's education. So here we have 0 to 20, and here we have 0 to 20. Now I just have it spaced out 0 to 5, up to 10, and spaced out in 5-year increments, and here it's spaced out every 2. But that's just a matter of the scale. But it doesn't matter how the scale is in that respect. The question really here is there a relationship? And I drew a red arrow here to signify that there is a relationship, because you can sort of see the number of dots kind of go up, right? You can sort of, qualitatively, you can predict that these dots are going up, and if this was going to go higher and higher and higher, it'd go up this way. So I just drew a line right through it, just like that, to show that I feel like that's the direction that arrow is going. So there are two things that you need for a scatter plot description, okay? You need the strength of the relationship, and you need the direction of the relationship. So in this case, the strength is strong. It is a very strong relationship. The stronger the relationship, the more vertical that relationship will be, right? If it's flat, if it's horizontal, there's not a very strong relationship, okay? So here we have from bottom left to upper right, a very strong relationship, and that relationship is positive. And it's positive because as one variable goes up, so too does the other, right? So it's a positive relationship. The slope is positive. So slope is up 1 over 1, up 1 over 1, right? So if it's up 1 over 1, up 1 over 1, up 1 over 1, that's a positive relationship, okay? And again, it's strong, which is essentially all me saying it's strong. I mean, there's no number that says it's strong or not. It's just me thinking it looks like it's a strong relationship. That's why it's called a qualitative measurement. Here I'm looking at mother's education and the number of cigarettes smoked per day. And this is using actual data from the state of California. So you can see here that the more education the mom has, the fewer number of cigarettes smoked per day, right? So if she has very low education, she's more likely to be smoking higher amounts of cigarettes per day. But that's not, again, if you look at the data without these lines, without this red line or even the black line drawn in there with a regression line, it's not terribly noticeable which direction that relationship actually goes. In fact, if I were to remove those lines, you probably would have a hard time saying that there was any relationship at all. If any, it would be a weak relationship. And if it's a weak relationship, it's likely a negative relationship. In other words, as one variable goes up, the other one goes down. So as the number of years of education go up, the number of cigarettes smoked goes down. Up. If the number of years of education go up, and the number of cigarettes goes down. Okay, so it's going from top left to bottom right is a negative relationship, and it's very, very, very weak. Weak is understatement in this relationship. Again, if you take the lines out, the lines would, it almost seems like it should go almost completely horizontal. If it goes completely horizontal, then it's a 100% weak relationship which likely doesn't even exist. But the stronger the relationship you see, the more obvious the line will be in the scatter plot. In a perfect linear relationship, all points will actually seem to be grouped fairly close to a straight line. And with no relationship at all, the points will be seemingly scattered at random. 2 points here, very important. A strong relationship does not mean there is a true relationship. It's really only a qualitative measurement, okay? This is, again, we're hounding on this idea that causal relationships are really hard to prove, and that there's potentially other factors feeding into the relationship that you're actually looking at. A weak relationship, which again, I understand this is misspelled. This should be W-E-A-K, sorry. A weak relationship does not mean there is not a relationship. It's only a qualitative measurement, okay? So again, just because I see here that there's a weak relationship between mother's years of education and number of cigarettes smoked per day, just because that's weak does not necessarily mean that it doesn't exist. In fact, that might actually exist. It's just a weak relationship. So that's scatter plots. The last type of measurement we're going to use, type of method for assessing the bivariate relationship, is the correlation coefficient. So this is a method that actually assigns an actual numeric value to the relationship between two variables. Okay, so it gives a numeric measure of the strength and the direction, much like a scatter plot, but it assigns an actual quantitative value to that relationship. And the correlation coefficient has a max value of a 1 for a perfect positive relationship, which is a straight line, and a correlation coefficient has a minimum value of a -1 for a perfect negative relationship, which is also a straight line. A correlation coefficient with a 0 indicates no relationship. And I will give you a perfect example. Well, not necessarily perfect, but I'll give you the best I can. So here we have the correlation coefficient matrix, okay? A correlation coefficient matrix of education, father's education, mother's education, family income, and birth weight, okay? So family income is a measure that assessed how much money the family was making, and the birth weight of the child. So if you notice in this correlation coefficient matrix, we have 4 variables: father's, mother's education, family income, and birth weight, and the same exact variables going down the rows: father's and mother's education, family income, and birth weight. So the relationship between father's education and father's education, which because of the same exact variable, the relationship is a perfect 1, okay? And that goes as well for mother's education and mother's education. It's perfect 1. And family income, 1. And a birth weight and birth weight is a 1. So if you look at the diagonal here, it's 1.00, 1.00, 1.00, and 1.00. So again, a perfect relationship is something described as one goes up, so does the other, and in a perfect manner. So if one variable is related to itself, father's education is related to itself, obviously, then it's going to be a perfect 1.00. So if you were to graph this out, it'd be a perfect line. And so would this mother's education, father's family income, and birth weight. The further from the 0 in either direction indicates the strength of the relationship, okay? So 1.00 is a very strong, in fact, the most strong, or the strongest relationship you can have. And if you had any negative numbers, and it was a -1, if it was a -1, it would be the strongest relationship you could possibly have in the other direction. But a relationship of 0.07 is very, 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 very close to 0. And a 0 means no relationship exists at all. The sign of the coefficient actually indicates the direction of the relationship, and in this case we have all positive relationships, right? So as one variable goes up, so does the other. So as father's education goes up, so does mother's education. As father's education goes up, so does the family income. As father's education goes up, so does birth weight. And those are all self-explanatory in a lot of ways. I mean, we understand that, it's more likely that someone with a higher education will be married to somebody with a higher education. Father's education goes up, so does the mother's. It's also understood that the more education you have, the more likely you are to get a job, right? So the father's education, as it goes up, the higher the family income. And again, the more educated you are, the better access you have to healthcare. And a good indicator of healthcare is birth weight.